Hello everyone. In this video, we will study the truth tables for the conditional and biconditional connectives or statements, right? Now, we know that a conditional statement is an if-then statement. And in an if-then statement, there are two statements. One statement goes with the if, and we have the word then, followed by another statement. So we denote the statement that goes with if as a P, and the one that goes with then is a Q. Now, the part that goes with if is also called an antecedent, and the part that goes with the then is called a consequent. So what it essentially means is that something will result if a condition has been met, and that condition is called the antecedent. All right, so we will learn how to develop truth tables for if-then statements. So what's the symbol used to denote a conditional if-then statement? It is this one directional arrow pointing to the right, and it reads as if P, then Q. All right. So now we will go ahead and set up the truth table for the conditional statement, correct? So we start by writing the symbolic statement. Over here, it's going to be P, and then on the other side, there's going to be the Q, and in between the one directional arrow. We know that for two statements, when we work on truth tables for two statements, then the number of unique combinations of true and false values is going to be 4. How did we know that? The formula to determine the number of combinations, unique combinations, is 2 to the power n, where n represents the number of statements with which we are creating the truth table, correct? So we have two statements here, therefore n is going to be 2, so 2 squared is a 4. So we'll have 4 rows of true and false combinations. So to create the combinations, we start with the statement on the right hand side. In this case, it's Q, and we alternate the true and false values starting with true. So TF, and we stop after 4 rows, all right, because we know the total number of rows we should expect is 4, correct? So TF for Q, and then we go to the statement on the left hand side, which is a P, and for this one we are going to double the number of true and false. So it's going to be TT and FF, all right? So now we have all possible combinations of true and false for P and Q together. So we can go ahead now and perform the evaluation of the truth values. Now for conditionals, the only time that we are going to get a false is when the if condition is a true, but the then condition is a false, which is the second one here. All right, so let me just kind of circle or square this up, box this. All right, this is the only time that the evaluation is going to return a false, when the if condition is a true, but the then condition is a false. All other combinations will result in a true. So when P is true and Q is a true, we are going to get a true. If the first condition, if P is a false and Q is a true, we are going to get a true. If both are false, it's still going to return a true. All right. So this is the truth table for a conditional statement. Again, to help you remember, the only time the evaluation is going to result in a false is when the if condition is a true, but the then condition Q is a false. Now let's look at the truth table for biconditionals. Now, biconditionals use the phrase if and only if. So in the biconditional statements, you will find the phrasing if and only if these conditional conditions are met, then such and such will happen. All right. What is the symbol for denoting biconditionals? It's a bidirectional arrow. That means the arrow points to both the left-hand side and the right-hand side. And on either side, we have our statements P and Q. And when we set up the truth table, then again, it works the same way as building any other truth table. We start from the statement on the right-hand side and we alternate the true and falses. So true, false, true, false. Again, the number of combinations would be 4 for two statements. And then for the statement to the left, which is a P, we have to double the number of true and falses. So it's going to be true, true, and false, false. All right. So now that we have set up our truth table, we have to evaluate the truth values for the biconditionals. Important thing to know is whenever the statements have the same truth values, it'll always return a true. So as long as both the statements have the same truth value, whether they be true or false, it'll always return a true. Whenever they have opposing truth values, that means one is a true, the other one is a false, and vice versa, then it'll return a false. So based on that, let's fill in the truth table. Since both are true, to begin with, true and true, they have the same truth value, it will result in a true. True and false are opposing truth values, it will result in a false. False and true returns a false. But false and false, because they have the same truth value, will result in a true. So this is how the truth table for biconditional looks like. So I'm going to box the ones that are false, like I did for the previous conditional truth table. Whenever the truth values of the statements are opposite, then it'll always result in a false. For a statement, for a truth value to be a true value, both the statements must have the same truth value. All right. Now let's try to build a truth table for the given statement here. It reads as, it is false that if Elaine went to lunch, then she cannot take a message and we will have to go home. All right. Now, before we go ahead with the truth table, let's try to identify what connectives or negation this particular statement has. We see there is an if-then phrase, so that makes it a conditional. It is not a biconditional because we don't see the phrasing if and only if. So I'm going to underline the if-then, so we know it's a conditional statement. And then, are there any other connectives that we should note? There is an and, which is a conjunction, so we have to keep that in mind. Then there are some negations, correct? There is a negation here where it says she cannot take a message, so this is going to be a negation. And also, to begin with, it starts with it is false, therefore that is also a negation. That is also a negation. So we have identified the connectives and negation in this statement. Next step is to break it up into simple statements, and eventually we will rewrite the statement in symbolic form. All right. So we have P. We will have P indicate the first part of the statement that goes after the if. So Elaine went to lunch. Let's represent that as P. All right. So Elaine went to lunch. And then we have the next one represented by Q. All right, so whatever comes after then, she cannot take a message. Well, remember, we should not include a negation or any connectives while writing the simple statement. So we'll have to write it as she can take a message. That's going to represent the second statement. She can take a message. Later on, we are going to negate that. And the third statement is we will have to go home. So let's represent that with R. So that's going to be we will have to go home. Have to go home. So we have these three statements together. Now Q and R are a part of the then. All right, this is a part of the then, whereas P is the part that goes with the if, correct? So let's try to write it out as in symbolic form. If Elaine went to lunch, that's P. So we are going to have P, all right, P. And then it's a conditional, so we have to put our symbol for conditional, which is a one-directional arrow. Then she cannot take a message and we will have to go home. So there are two simple statements connected with the and. So it's going to be Q and R, Q and R. However, for the Q, there's a negation involved, so we have to negate the Q, and we have to surround that with brackets because that's one unit that goes together. It's all a part of the then clause, all right? And then there is this false to begin with, so this whole entire statement at the end of the day has to be negated. All right, so the symbolic form of this entire statement, it is false that if Elaine went to lunch, then she cannot take a message and we will have to go home, is represented as not, and then we have an outer bracket, if P, then not Q and R. All right, so we have to build a truth table for this symbolic statement. So now let's go ahead and construct the truth table for this compound statement we just created. All right. Note that there are three statements this time. It's not just two statements, P and Q, but we have a third one, which is R. So when we set up the truth table, then we are going to have 2 to the power 3 combinations. So it's going to be 2 to the power 3, 3 being the number of statements we are working with. So that's going to be 8 unique combinations of true and false values for 3 statements. So let's create or set up those unique combinations. We're going to have a P, a column for P, then one for Q, and then one for R. And we start with the rightmost statement, which is R in this case. And we are just going to alternate TF, TF, but it's going to go over 8 rows, not 4 rows. So TF, TF, then we have TF and TF once more. Then we turn to Q on the left hand. We are going to double the number of T's and F's in the sequence. So it's going to be TT, FF, TT, and FF. Now we have to fill in the values for P, and that's going to be double the number of T's and F's, double of the number that we had in Q, in the column for Q. So we had 2 T's followed by 2 F's. For P, it's going to be 4 T's followed by 4 F's, and that's going to be over 8 rows. So it's going to be T, 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 and then F, 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 TF. And that gives us all the combinations of true and falses that 3 statements could take. All right. Now, in the next step, we are going to write our symbolic statement over here in columns. All right. We're going to start with the outer negation. So this is how it's going to be. Let's pull out a different color. All right. So the negation, the outer negation. All right. And then we have an outer bracket. And then we have the P followed by the conditional symbol, and then an inner bracket followed by the negation of Q, and then the AND symbol followed by R, close the innermost bracket and close the outer square bracket. All right. So we are going to go through this step by step. We always start with the innermost bracket. Just like in order of operations, we always do the work the innermost bracket first. It's the same thing here. And within the innermost bracket, we are going to tackle the negation first. And what are we negating? We are negating all the Q values, correct? So in negation, the true will become a false and the false will become a true. So let's just write down those values, right? So we are going to have the trues made to a false, then we have another true that would become a false, then the false would be a true, all the false would become a true, and all the true would become a false, correct? So we are done with the negation of Q. The next step is to work on R. Now, there's no negation for R, so nothing changes. You can just copy the values that we have listed here for R, and let's write as TF, 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 all the way down to the 8th row. All right, TF. And now we can go ahead and evaluate the AND. What is the rule about the AND table? The only time that an AND results in a true is when both the statements are true. Otherwise, it'll always end up being a false. So false and true, and this time let's use a different color. False and true will result in a false. False, false will result in a false. True, true results in a true, and that's the only time an AND will resolve to a true. True, false gives us a false. False, true is a false. False, false is a false. True, true is a true. True, false is a false. All right, so we now evaluated the AND. The next step is to move outside of the innermost brackets. Because we are done with that, let's move outwards and we work on the P. Again, P is as is, so we just write down all these true and false values in the first column. We are not negating anything, so we just write T, T, T 4 times, and then followed by 4 Fs. And once we have that down, we are going to evaluate the conditional. So which are the columns we are evaluating this time? It's P and this AND values, right? So I've highlighted them. This is what we are evaluating at this point. This is a conditional if-then statement. The only time that a conditional resolves to a false is when the first one, when P is a true and the Q, the then condition is a false. All right, the then part of the clause is a false. So if the first one is a true, the second one is a false, then it'll resolve in a false. Otherwise, it'll always be true. Correct? So let's fill out this table here. We are going to have true, false will result in a false. All right, so this time it'll result in a false. True, false results in a false. True, true results in a true. True, false results in a false. False, false results in a true. False, false results in a true. False, true results in a true. And false, false results in a false. All right. So that is the evaluation of the conditional. So now this time I'm going to color it with a different, let's use the gray. All right. So this, we have evaluated the conditional and we have worked everything that is within the brackets, in the outermost bracket. Next step is to work on negate the outer negation, right? So negating, what are we negating? We are negating this conditional, all right? So we are negating this, whatever is under the conditional symbol column, right? So that's easy. Just reverse. If you have a false, that make that a true. If you have a true, make that a false. All right. So we're going to end up having the false become a true. This is a false, that make that a true. The true becomes a false. Then the false becomes a true. The true becomes a false. The true becomes a false. The rest of it is all false. All right. And this is the final truth value of the entire compound statement for this example. All right. So just circle the final truth value resulting from the truth table for this statement.